Math 1314, section IC1, spring 2022, Tyler Junior College. Homework 9.5/9.6, exponential and logarithmic equations. Video 5, solving logarithmic equations, part 1. Something out of the screen there. There we go. All right. Anyway, so I'm anticipating parts 1, 2, 3, and possibly 4, plus one more for application. So I'm expecting 5 more videos, but let's see how this plays out. Now, just like in the previous videos in the series, these questions are coming directly from the homework, and I'll show them to you as we go through them. All right. Now let's start with a definition that I'm going to use. This is not an official definition. In this video, a type 1 logarithmic equation is an equation that contains some terms that are logarithms and some terms that are not logarithms. Let me underline those two important things. Contains some terms that are logarithms and some terms that are not logarithms. When the time is right, I'm going to create a list titled How to Solve Type 1 Logarithmic Equations. Now, by contrast, in later videos, we will look at type 2 logarithmic equations in which all terms are logarithms. You'll see what I mean in a moment. It should be noted that these definitions are not standard. The professor, that would be me, is using them to identify two similar but slightly different solving techniques. You'll see what I mean when it's all said and done. Trying to figure out what that thing is in the, well, whatever, that thing keeps popping up right there, whatever. All right, so anyway, let's take a look at the first example. And this one is pretty simple. Solve the equation log base 2 of t is equal to 6. Now, this isn't very deep into the homework. I'm finding it so I can show it to you. I want to say it's question number 9. Maybe it's question number 10. Yes, let me share it with you. So this comes directly from question 10, where it asks you to write the solution set with exact solutions. So no calculators, no decimal approximations, just tell me exactly what you get. I do want to remind you that sometimes parentheses are not used around the arguments of logarithms in the homework when the argument contains a single term like t. My preference, however, is to be consistent. Come on, hold on. There we go. My preference is to be consistent and use parentheses around arguments every time I type a logarithm. All right, so how are we going to solve this? Well, let's think about this in terms of what our goal is, because it's all equation solving is a goal-oriented task, and the goal is to figure out what the variable equals. So we need to get this t by itself. The problem is the t is currently located inside a logarithm. Sorry for the yawning, folks. The t is currently inside the argument of a logarithm. And so in order to solve for t, we're going to have to somehow get it out of there. Now, if you're thinking, let's use the power rule. Well, the power rule is when you have a power up here, and then you can pull that down. Well, that would pull a power out, but it's the t that we're trying to get out of the logarithm. So the power rule wouldn't work there. So what can we do? Well, what do we know about all logarithms? The answer to a logarithm is a power that turns the base into the argument. Just a reminder about what all these things mean, because I haven't drawn this in a while. The answer to a logarithm is a power that turns the base into the argument. I'm not sure that's going to fit. Okay, so the words ran into each other. I can fix that. You come over. You stay there. I want the power. I want the power. Sorry, things are not cooperating much. And I'm going to say the statement again because it's kind of lost its flair. Plus, I apologize. I've got about 3 dogs at my feet, and they're all acting kind of goofy. The answer to a logarithm is the power that turns the base into the argument. So we can rewrite this in exponential form, and that will remove the argument from inside the logarithm. 1 second, folks. Sorry about that. One dog was trying to eat the other dog's face in a loving way, of course. All right, so we are going to attack this by rewriting this equation in exponential form. And eventually, this is going to become a move in a sequence of moves. So let's rewrite in exponential form. And to do that, all we have to do is remember who is the power, who is the base, and who is the argument. The answer to a logarithm, in this case 6, is the power that turns the base is the 2, into the argument. The argument is the t, so the t will go on the right side of that equal sign. And at this point, we're practically done because our goal is to make it say t equals. Now, granted, it says equals t, but equations are reflexive in the sense that if you say this equals that, then you can just say that equals this in the reverse order. So we can just say t is equal to 2 to the 6th power. But I would like to know what 2 to the 6th power is, so we could just either raise 2 to the 6th power in a calculator or do what 2 to the 6th power means, which is 2 times 2 times 2 times 2 times 2 times 2. And if you do all that, you get 64. Well, that was pretty easy. As long as we know the key move, and the key move in this case was to rewrite in exponential form. Now, this won't always be the first move, but for type 1 logarithmic equations, it will be a move. And remember, by type 1, I mean a logarithmic equation in which some of the terms are logarithms, such as that one, and some of them are not, such as the 6. So you got some logs and you got some non-logs, if you will. All right, let's take a look at another example. Let's go back to the homework and grab a question. Let's see. Oops, that's not what I meant to share. Let's try that again. Share. There we go. I guess we can put this answer in. The solution set is 64. Oh, wait a minute. I forgot to put the braces around it, but it said that's okay. And notice it even would have accepted 2 to the 6th power. How nice of it. Let's see. What's this one? Oh, let's do this one. Log. Well, there's no base written. Log of c is equal to 27. Log of c is equal to 27. Log of c is equal to 27. Well, we're still going to start by rewriting this, rewrite in exponential form. But in order to do that, we have to know what the base is. You remember what the base is when you have log with no base written. We call that log with no base, means log base what? Log base 10. So if it helps, you could actually write the base of 10 in there. It's not necessary. It's implied to be there when it's not written. But if it helps, write it. And remember that the answer to a log, which in this case is the 27, is the power, which means the 27 is going to be the power on something that turns the base, which is 10. So the power goes on the base, and it turns the base into the argument. So 10 is the power that turns 27, excuse me, said that backwards. 27 is the power that turns 10 into C. Watch again as I say it again. 27 is the power that turns 10 into C. And just like before, we have practically the equation solved because it says C equals, or rather it says equals C, but we could easily turn that around and say C equals 10 to the 27th power. Now, do we want to work out 10 to the 27th power? It wouldn't be that hard. You would just have to write 1 with 27 zeros. I can probably type it faster. 1 with 27 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27. All righty. Now, do we want to write that? No. Can you read that number? I would bet that you couldn't, but I can. Million, billion, trillion, quadrillion, it's 1 octillion, O-C-T-I-L-L-I-O-N. But I wouldn't expect most people to know that because not everybody's a big nerd like I am. So which answer do we put? Do we put 10 to the 27th or do we put 1 followed by 27 zeros? Let me make sure I call it the right thing. Million, billion, trillion, quadrillion, quintillion, septillion, sextillion, octillion. Yes, 1 octillion. I'm kind of curious if it'll let me type in the one with the 27 zeros. So let's find out. I just really want to know. 1, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16, 17, 18, 19, 20, 21, 23, 24, 25, 26, 27. I'm just curious if it'll take that. I broke it. I broke it. I did put 27 zeros, didn't I? I did. I broke it. They want 10 to the 27th power. I bet. Oh, or in braces. I really wish you would have taken the 27 zeros, but that's just me being goofy. Okay, let's find another question. But so far, these two have run the same course. Rewrite in exponential form, and it's practically over. So what could possibly go wrong? Well, let's find a question where things change. That's not really any different. Do you remember the base for natural log? The base for natural log is the natural base e. And so what would this equation be if I wrote it in exponential form? 11 is the power that turns e into y. So we'd have e to the 11th power equals y, which means the solution set, and I guess I'll type it in braces, would be e to the 11th power, or approximated to 4 decimal places. Well, if I take e and raise it to the 11th power, where's my e to the button? There it is. Well, it's not that big. It's only 59,000. Let's copy this. Well, it can I not copy here? Let's find out. That's the answer I got in a calculator, but it wanted approximated to 4 decimal places. Let's see what happens if I don't. It actually took it. Oh, and it's only complaining about not being in braces. That's okay. All right, so anyway, that one's not really any different. So 10, 11, 12, they all run the same course. Rewrite the equation in exponential form and see what happens. That's different. It's got a lot of junk around the logarithm. So does this one. Okay, things are getting junkier now. Let's go back to number 14. We could do 13, but 13 and 14 are pretty much the same. They may not look the same. It's just that the numbers are different. This log has a base 6. This log has a base e. We're going to do number 14, which I already have set up. Make sure I've got it written correctly. It's 3 times the natural log of 9 minus 5, whatever the variable is. Oops, I got the equation backwards. It should be 9 minus 5t, not 9w minus 5. All right, let me fix that. 9 minus 5t, or w. It really doesn't matter what letter we use. I'm just trying to preserve the same equation that is in the homework. 3 times the natural log of 9 minus 5w, or t, and then outside that, plus 2 is equal to 11. All right, so why is this problem different? Well, I think it's fairly obvious that the reason it's different is because these first 2 examples, or the third one that we did in the homework, this log is already ready to rewrite in exponential form. This one is not. And the reason it's not is because the logarithm in this problem, the natural log, is not yet isolated. It's got the 3 multiplied in front and the 2 added to the end. So what are we going to do? Well, we're going to make up a new step to do first. So first, we need to rewrite the equation as log equals number. And for a type 1 equation, you should always be able to get that, because there should be a non-log, aka a number somewhere in the equation. So how would we do that? How would we rewrite this so it says log equals a number, or in this case, natural log equals a number? Well, the answer is we have to isolate the logarithm, and the logarithm is currently sitting right here. So let's throw a box over it for a second, and don't treat it like a logarithm. Let's just say it's a rectangle. All right, 3 times rectangle plus 2 equals 11. Well, that's pretty easy to solve. If we wanted to solve for the red rectangle, we would just subtract 2 from both sides. That would cancel the 2's on the left. That would leave us 3 times big red rectangle. That's not red. 3 times big red rectangle. 2's cancel. And then on the right side of the equal sign, 11 minus 2 is 3. And then to get rid of the, 11 minus 2 is 9. I'm getting ahead of myself. And then to finish getting the red box by itself, we would divide both sides by 3. And we would get big red box is equal to 9 divided by 3 is 3. That's the reason I wrote 3 a minute ago. But that's if we were solving for just big red box. But what was under the big red box? A natural log of 9 minus 5w, which means each of these red boxes is the natural log of 9 minus 5w, including this one down here. Natural log of 9 minus 5w. I like covering things up because sometimes the things that you're solving for are big and chunky and they get in the way. So you just got to stop looking at them for a while and bring them back when the time is right. Now, we're not done, because this equation does not say W equals, but now it says log equals a number. It says log equals a number, just like this problem started out, log equals a number, and just like this problem started out. And when we started out there, we just rewrote an exponential form. So we just have to do the same thing now. All right. Let's move all this writing over just for, not that. Let's move all this writing over so I can make myself a little bit room. I hope I grabbed everything. I did. All right, let's continue. And now at this point, we'll put this in red and we'll take the font size down 1. Now, now rewrite in exponential form. We have to get the logarithm by itself before we can do that. The base of natural log is e. And so the answer to a logarithm, which in this case is 3, is the power that turns the base into the argument, 9 minus 5w. Now, do we evaluate e to the 3rd power? I would not. My goal is to solve for the w. So let's start by subtracting 9 from both sides, or rather trying to subtract 9 from both sides. I say try because e to the 3rd power minus 9 is something I do not know the answer to, so the best I can do is just write this. E to the 3rd power minus 9 equals negative 5w. The 5 is negative, and it still is. And then to get the w by itself, we can divide both sides by negative 5. And when we do that, we get w equals this fraction, e to the 3rd power minus 9 all over negative 5. Let's try putting that in our answers. Okay. There is a solution. The exact solution set is braces, fraction, e to the 3rd power. I believe it was minus 9 divided by negative 5. Let me double check the whiteboard just to make sure that's what I had. E to the 3rd power minus 9 over negative 5. It is. And then they want a decimal approximation. Now, some of you have contacted me about how to put this in your calculator. The answer is it depends what your calculator is. So if you need some help putting something like this in a calculator, please contact me. I can have one-on-one FaceTime with you or a Zoom session. Or if you send me a picture of your calculator, I can tell you exactly how to press the buttons to put in a certain answer. But for my calculator, I'm going to do e to the 3rd power minus 9, press equals to complete the subtraction problem, and then divided by negative 5. And what I get to, let's see, 4 decimal places is negative 1.3856, except the next number after the 6 is 9. So if I'm rounding up to 4 decimal places, that 6 would go up to a 7. Really? Let's make sure I did not miswrite the number. I did not. Let me make sure I put it in my calculator correctly. E to the 3rd power minus 9 equals divided by negative 5. I must have pressed something wrong in my calculator, because that's not the number I got in my calculator this time. negative 2.2171, and the next digit is 0, so the 1 doesn't round up, it rounds down. Not sure what I pressed in my calculator the first time, but hey, at least we get 3 shots at it. Okay, so let's summarize what's happened real quick before we wrap up this video. When you're solving what I call type 1 logarithmic equation, where some of the terms have logs and some do not, if that log is equal to a number, such as in this first example or the second example, then your move is to rewrite an exponential form. But if it's not, like in this example, then we had to first rewrite the equation as log equals a number and then rewrite an exponential form. But something else happened in this problem that didn't happen before. After we rewrote an exponential form, which in this problem is right here, we weren't done because it didn't say W equals. I am so sorry, folks. I need to get some caffeine in my system. In these previous examples, the argument was just the variable. And so once we rewrote an exponential form, we were practically done. But in this example, it was not. The argument was actually more than a variable, meaning that once we rewrote an exponential form, we had more work to do. Don't worry, this is all going to get cleaned up real nice in the next video. Why the next video? Well, because we haven't talked about equations like this, which is a type 1 log, because some of the terms are logs, that's 2 of them, and some of them are not. This term here is not a log. So what do we do for this one? Well, let's talk about it in the next video.